Okay, this is Module 3, Lesson 3, Modeling with Functions. Okay, the previous lesson, Module 3, Lesson 2, was helping us to understand relations and functions. Relations, remember, are just ordered pairs. Some relations qualify as functions. So, and remember we do like the vertical line test to determine if it's a function. If it's a function, so now we're going to start modeling with functions. All right, so first thing, it says to identify independent and dependent variables. The input of a function is the independent variable. The output of a function is the dependent variable. The value of the dependent variable depends on, or is a function of, the value of the independent variable. Basically, in regular words, the independent variable determines the value of the dependent variable. The x-axis or the x value determines the value of the y. Okay? All right, identify dependent and independent variables in each situation. Okay, A. All right, I'm not sure why they did the A, B, C, D, E, but anyway, here's the first statement. It says, in the winter, more electricity is used when the outside temperature goes down, and less is used when the outside temperature rises. So, the amount of electricity used depends on the temperature, okay? The amount of electricity used is a function of what the temperature outside is doing, okay? All right, your independent variable is your temperature, because your temperature is going to determine the amount of electricity used. So temperature goes on the x-axis. If you were going to graph this, amount of electricity used goes on the y-axis, okay? But these two things are considered a function. They are a function of one another. The amount of electricity used is a function of what the temperature is doing. Let's try another one. The cost of shipping a package is based on its weight. So, the cost depends on the weight of the package. Cost depends on weight. The dependent is the cost. The independent is the weight. The weight determines your cost. So your weight would go on the x-axis if you were to graph it, and the cost would go on the y-axis. The faster Tom walks, the quicker he gets home. Okay, so they don't really call it time and speed, but that's basically the two quantities you're looking at. How long does it take him and how fast does he walk? So the faster Tom walks, the quicker he gets home. Okay? So the time it takes him to get home, in this case, actually depends on the speed he's going to walk. Okay? So the faster the speed, the less time it takes him to get home. Speed is going to be, in this case, your independent variable because it's going to determine how long it takes for you to get home. I will say this, just in general, in science and whatnot, most of the time will be an x value because there's so many things that depend on time. But in this particular case, time was the y value, just simply because the amount of time it took to do something was dependent on the speed at which it was done. Okay? All right, join me on page 122, where it's talking about applying function notation. If x is the independent variable and y is the dependent variable, then you can use something called function notation to write y equals f of x, which is read literally y equals f of x, where f names the function. When an equation in two variables, like meaning x and y, describes a function, you can always use function notation to write it. Usually we just use y is f of x. But anyway, basically the way that this reads, this is all of this. The dependent variable, which is your y, the dependent variable is a function of the independent variable. Basically, the dependent variable is determined by the independent variable. Y is a function of x. Y is a function of x. So y is a function of x. Y is determined by what x is doing, is basically what they're saying. And you need to understand that this is just simply, this is called function notation. Okay? Write an equation in function notation. Amanda babysits and charges $5 per hour. Okay? The amount of money earned is $5 times the number of hours. Okay, so what is that going to look like when we start to write it as an algebraic equation or an algebraic expression? An algebraic expression that defines a function is a function rule. Write an equation using two variables to show this relationship. The amount earned, y, the amount earned is depending on all of this stuff. Amount earned equals 5 times the number of hours worked, which is x. So the number of hours worked is what is going to determine how much you earn, which is the y value. Okay. The dependent variable is a function of the independent variable. Write the equation in function notation. Okay, that's we're basically going through, and instead of saying y, we're going to say it's a function of x. These two things are basically saying the same thing. Okay, so up here we left it as y equals 5x. Okay, y equals 5x. Here we're just reminding ourselves that it's a function of x, like what you wind up getting is a function of how many hours you worked, and we can write it in function notation instead. Okay. Okay, this for a little reflection question says, can y be used instead of f of x in function notation? No, because function notation is you writing it f of x, okay? So if you're not writing it f of x, then you're not writing it in function notation, okay? Okay, so let's look at this kind of in action. The value of the the value of the dependent variable depends on, or is a function of, the value of the independent variable. If x is the independent variable and y is the dependent variable, then the function notation for y will read f of x, where f names the function. We'll show you what I mean in just a second. When an equation in two variables describes a function, you can use function notation to write it. So here's an example. For each example, identify the independent and dependent variables, write an equation in function notation for each situation, and then use the equation to solve the problem. Okay, so here's the situation. A lawyer's fee is $180 per hour for his services. How much does the lawyer charge for 5 hours? Okay, well, the fee he charges is going to depend on how many hours he works. So the dependent variable is going to be the fee because it's going to be determined by the independent variable, which is the number of hours that is worked. Okay, so this is your x, and this is a function of whatever that x is. Okay, so let h represent the number of hours the lawyer works. The function for the lawyer's fee is f of h is equal to 180h, where h is the number of hours, okay? So the fees are a function of the number of hours that are worked, okay? So f of 5 is equal to 180 times 5, okay? So the lawyer charges $900 for 5 hours of work. Now, you put this little 5 in there, and you're not going to do anything like multiplying wise, but you're just saying that the fee is going to be a function of working 5 hours. Okay, so there's not anything you're doing mathematically with that, but you do something with it over here. 180 times the number of hours they worked gives you your fee. Okay, so just make sure that you don't get caught up thinking you've got to do something with this 5. It just says that it's a function of working for 5 hours. Okay, we've got another example. It says the admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go to the carnival and then go on 12 rides? All right, well, the total cost depends on the number of rides plus $9. Number of rides plus $9. So your dependent variable is total cost. And your independent variable is your number of rides. Let R represent the number of rides. The function for the total cost of the carnival is going to be a function of the number of rides that you take, okay? Because it's going to be $1.75 for each ride plus $9. Substitute 12 for R into the function for the total cost of the carnival and find the total cost. So the function for 12 rides, the cost is going to be $1.75 times 12 plus 9. So the cost for 12 rides, that's f of 12 basically, is going to be $30, because when you chug all of that out, that's $30. So it costs $30 to go to the carnival and go on 12 rides. So once again, you're just putting the 12 there because the cost is a function of going on 12 rides, okay? You're not doing anything mathematically to this. You're not like moving it to the other side or anything crazy like that, okay? You're just showing me that it's a function of going on 12 rides.